time. Okie dokie. So I'm Michael. I don't need to introduce myself again because we did introductions earlier. But my collaborator, Nick Haggerty, who's also in the operations section, was originally going to give this talk, but also Nick isn't looped into the quantum world like I am. So I stepped in. And also, he's a very busy dude. A lot of discovery quarterly stuff going on, and they're accepting 3 systems right now, at least. So he's very busy. But I'm here to talk about what essentially is lessons that I want to pass on to y'all in the openQSE community of stuff that the HPC operations section here at Oak Ridge cares about. And a lot of these, one, have already been brought up by a lot of other presentations, but 2 are still open-ended questions where I don't necessarily have answers for, but I want to at least put them out there as something that we care about. Just to give an overview of where I sit on what actually this means. So in Oak Ridge, we have, of course, divisions and sections and things like that. So we have the National Center for Computational Sciences. That's where I sit in the operations section. NCCS supports OLCF, but that's not the only program it supports. So, for example, it supports the QCUP program, which lives also within NCCS and LCF, Air Force, NOAA, you name it. But this is just our org chart here. We have the systems group, who are the sysadmins, the operations folks like me that handle the day-to-day operations, the science engagement team, which are historically the science experts publishing all the time. But there's this new group down here called the Quantum HPC group, which is sort of a mix of folks from advanced technologies and those across the section to form this new integration group. And so, although I sit in a different section, I have a very close relationship with the Quantum HPC group here. Ryan's here as well, who's part of that. But just to do a deeper dive into the various groups that I will be speaking on behalf of today and their concerns about QC HPC integration. So as I mentioned, we handle the day-to-day operations of our production resources, so not the test beds, but systems on the way to production as well. So for example, Frontier wasn't accepted at some point, but of course we still had to do testing and had pre-acceptance and all transition that up to what it is today. So we have the accounts team, also known as their long name of user access, outreach, and communications, or those are the folks that onboard all the users and deal with all of the folks wanting to submit proposals to the center, right? We have the software services development team, SSD, who are the folks trying to do a lot of the automation with vendor API stuff for QCUP or for just our HPC systems in general. Data and platform services is a relatively new group in our section, and they're focused mainly on the Kubernetes side of things. So that's on the rise. They also help manage our publication streams as well for DOI data from our center. Then, of course, we have the beefy one, system acceptance and user environment. Those are the folks running acceptance tests on all of our systems for HPC and also deploying the software environment at the same time. And so even though in their name it's just acceptance, they're also testing the system as like Frontier during its midlife as well. They don't just stop their job after they accept the machine. They're always constantly testing. And I sit in user assistance, so documentation, training, debugging of bleeding edge workflows. So although quantum is new and it's very bleeding edge, we do bleeding edge all the time in our section. It's just another one of those things. So I now just sort of put out here, this is what all these groups care about. Or when I went up to their group leads and asked, hey, give me your thoughts on this. Here's some things. So for the accounts team, concerns that they brought up were, one, as always, that it's separated into things that aren't specific to QC and some things that are. So of course, volume of users, volume of applications that they have to sit through. This isn't particularly, may not be at least particularly interesting to y'all who are on the more software side of things or hardware side of things, but it's just something that the operations folks had to deal with, right? How many users are we expecting? Are there any restricted users? So for example, even on the IBM cloud, we have to have a user agreement between an institution, us, and IBM, right? Or maybe there's some restricted pass rules for security. So are there citizenship restrictions, export control, or things like that? And in general, what are we actually allowed to say about the machine? Can we actually publicize error rates on our website, which is what users would find interesting? But from a legal point of view, are we even allowed to touch that at all on both sides, on the Oak Ridge side or on, for example, IBM side, right? More specific to QC, how is time allocated? That's a theme here, not necessarily from on the tech side of things, but just how they grant time through a proposal process, like Insight ALCC? Is it a DT allocation? Is there a new allocation program that we haven't thought of yet? So, concerns from any council. SSD, I think, is the most interesting one to hear. And I swear, even though all of these are separated into basically their concerns and their thoughts and what they do, I played around with a PowerPoint formatting, so all of these look different. But yes, SSD stands up for something called RAS, which is our resource and allocation tracking system. So it tracks OLCF projects, the allocations they have, the users they have, the file system quotas, which directories they're allowed to touch. It also creates the Unix groups and various accesses that they would have on a given system or cluster. And this also is sort of a black box magic of what syncs with Slurm to impose partition limits for different QSs, right? So what they're concerned with, of course, are the allocation units. And everyone at some point has brought this up today. What are we charging? Is it node hour? So maybe if someone's not paying the entire QU, right? Is it more on the core hour situation where it's qubit hours? Unsure. At the very end of the day, RATS needs to know this information to enforce allocation penalties if we want to do that, right? Where on the HPC side, at least at our center, we don't turn people off if they, if they were allocated 10K allocation, if they are 10,001, they are turned off. They're just penalized in the queue on Slurm. So we have to think about that. Security enclaves are also important. QCup sits in open. The moderate quantum testbed Pathfinder system here is in the moderate enclave, and all of our production HPC systems are also moderate. So can things even talk to each other? And of course, as it's Slurm Center, it's mentioned being Slurm, it has special scheduler configurations per system to enforce different limits that might be on one system over the other. One thing that they brought up that I thought was interesting, and I think this has been touched on today, is that, and it's something that we're seeing with the on-site system that went online a couple of months ago, is the API behavior truly on-prem, or is it still, even though it's on-prem, still treated like a cloud-like resource? So for example, is there still a GUI that users interact with where they need to go in and click and generate an API token and submit jobs that way? I don't want that to be the user experience. I don't think that's what they want or security wants. And I think that's what Amir and QFW are trying to solve too, is sort of abstracting that away from the user, but still a concern from the SSD team. And of course, reporting capabilities. So based off of the allocation units we charge, DOE definitely wants us to plot how we're using the machine. It seems like a nice to have, but if we're going to report on a yearly basis of like, yes, we're using the machine, we have to tell them how, right? And just a heads up, even though this is very our own, I guess, software RAS, it is being deployed for the American Science Lab. So we're helping lead that, and we're sort of just tweaking RAS to be more asset-centric and are leading that effort. So even though it started out as an Oak Ridge product, it's becoming broader and broader use for a global scale. Next, the newer group. Not that many bullet points here, and I'm not a Kubernetes person, to be honest. But when I asked them about this, that's essentially their questions were, okay, with cloud style provisioning, how do things even map to Kubernetes? I know things are very Slurm centric right now, which I'm personally a fan of, but with certain systems and systems we're even investigating here, with things like Lux and upcoming systems, how does Kubernetes play a role of like, do we have a hybrid? Some nodes are Slurm nodes and some nodes are Kubernetes nodes. And if they are, how does Quantum hook into the Kubernetes part? Unsure. I won't mention Slate is a whole other can of worms. So we have this container orchestration service called Slate, where if there were GUI dependencies, we could utilize something like that internally, which is also Kubernetes based in OpenShift, but transitioning to Rancher. The bigger one, lots of questions here. So from Sowie's point of view, which is what system acceptance in user environment is, 4 separate boxes, I would say. So what they're concerned with is, okay, they have a definition of acceptance in the HPC world. And for them, at the end of the day, it's for FP64 things is checking reproducibility to make sure a certain benchmark is producing the same or similar results over and over and over again, right? And so due to the statistical nature of QC, how does that affect acceptance? What does that mean? And so that's what they're concerned with. And how do they know how if you sample for long enough, and I know that depends on application, right? Where is the line drawn in the sand? Because there has been a line like drawn somewhere. For
Trust us is not okay.
yeah, exactly, right. And so I sort of touched on this already, is where it's a lot of it's hardware dependent. Where if you're working on an ion trap or superconducting, right, it means different behavior for different mechanisms or different applications of different hardware, right? I added this parentheses at the bottom there because I thought it was an interesting talk at QCuff earlier this week where someone was testing benchmarking across different backends of how similar or one of their lines they draw was if the samples they were getting was just the same that they could see in a random number generator classically. I thought that was very interesting, and it very much depended on the type of hardware versus ion trap versus superconducting. And I touched on this a little bit, but yeah, clarity on acceptance. And this is something that we have to figure out internally at Oracle too. It's a bit awkward if we go back to this at the beginning here, where we have us in operations dealing with the day-to-day HPC world, but our QC HPC group is in a completely separate section of the lab, right? We want to make sure, like, okay, when do we step in? We have to clarify. There's vendor acceptance by like IQM, for instance, for its on-site system, but now the science engagement team needs to do their version of acceptance. But if we were to transition that to the production, not just a test bed, that we would have to do acceptance. So I feel like that term is getting a little bit overloaded, and I think we just have to be careful there. Like I said, internal discussions that we also need to figure out mainly, but I just thought I'd throw it out there. And from a software point of view, this is a lesson learned that we had from the Quantum Brilliance on-site machine, is that we want to be careful with software that depends on licenses. Of course, we always prefer open source software. But something that was interesting from a user point of view was, for example, Quantum Brilliance's emulator was proprietary, even though the rest of their software stack was open source. So if the user wanted to load the module to test, noise model to run their circuits, they would use LMOD to load the module. But even though they were fine with, oh yeah, just make the users, if they load the modules, then accepting a license agreement. From our point of view and from security's point of view, it's like, no, that's not what we want. No one's going to go just check the licensing agreement, say that, yeah, you're liable, right? So this is a lesson learned, that it's not as simple, even if you just say, yeah, it's fine. It's okay. Just nobody can, it's fine if someone has root and they can do anything with this proprietary software. So we want to be careful about that.
No, it's very simple. Acceptance is always the final stage.
Yeah, true, exactly. That's and then the last slide is my group. So I say why I say the most biased slide for last. So I say UA is the glue, and I'm sort of biased, but I say that because our group overlaps all of those other concerns, because we as a group have to support, if we're expected to support the full process, then we have to have a hand in every bit of the process, or at least be looped in. So for example, even it doesn't seem to make sense at first. Why does the user assistance team need to be calibration? But also like, okay, if we need to temper expectations for users, we need to be did over there, right? So if we're expected to support the full process, we appreciate being looped in to the process. We're often overlooked. So that's me fighting for my team. But from other points of view, best practices, and this is pretty generic. Yeah, passing along lessons learned about training docs, support, especially on the communication front. We don't want to overwhelm people with communication. That's part of my concern with quantum, is that with things going up and down a lot, we need to temper expectations to make sure it's like, okay, calibration on XYZ day, cadence, blah, blah, blah. Allocation policies that I mentioned before, change management procedures for software, also sort of covered from the previous slide. What I also thought was important, and this isn't new to quantum, but something that we found important on the HPC systems and within the QCup program, is needing to have a pathway for highly quantum-y questions, meaning we're highly qualified to answer coding questions and things like that because we do it all the time. But as far as the quantum background folks in UA, it's me and my colleague Jordan Weintraub, who is tangentially quantum and new. And other than that, everyone else is HPC. So there's problem there of more expertise is either needed to handle those internally, or we need to have a pathway open, like how with HPE, we have a center of excellence, where we can work with that vendor on Frontier, for example. So we might need to establish like a quantum center of excellence with the quantum vendor if we were doing integration like that for predictions. Yeah, exactly. I think it's sort of expected anyway and not new, but it's just very much hopefully doesn't get forgotten about. And I don't think it would. And then last, but yeah, not least, I mentioned uptime and downtime concerns. One thing I thought was interesting was the impact on non-quantum users. So depending on if we're doing an isolated set of nodes, or just doing a Slurm partition where the Slurm partition can, or QoS can talk to the QPU for everybody, what does downtime mean for the people that don't care about quantum, right? Just the pure HPC users. So I think we have to be careful there, where if the quantum machine goes down for calibration and we have a non-quantum user being like, wait, that just took down all of my nodes for whatever reason, we have to be mindful of how we lay the line there of taking which approach versus others for partition, QoS, HRES, things like that. Also, one lesson learned for health status, it's hard from, with compute nodes, they're up or down, right? Or in the most gray area, they can be in a degraded state. But from a file system, I think the QPU's health status is very comparable to monitoring a file system, where does your line in the sand for saying it's up or down? Where if you run an ls command and it hangs for X amount of time, does that mean it's different, right? There's different definitions there. And I think the same lessons learned with file system health status, we might be able to share some knowledge for QPU status. And I put some missed questions at the end, but just like you said, open-ended questions. This is something we have to figure out internally. Where does the specialized HPC integration line shift toward production, stopping a test bed? Because we don't want to reinvent the wheel. And in that vein, keeping us in the loop, even though it's not production yet, helps us stop reinventing the wheel or some things from being reinvented, right? I know Scott actually likes to ask this question, and I am a fan of this question as well. What warrants leadership scale? So meaning why I know the target and end goal is frontier discovery and things like that, but at the end of the day, we have to figure out what types of workloads or how common they are that actually need frontier instead of Anix, which is our analysis system, for example. CPU workloads versus GPU workloads, that sort of thing. And the can of worms where HPC node sharing is, how will that affect all of this? Because at this center, we have, at least for now, exclusive nodes by default, but I don't think it's going to stay that way. And just based off of what we're exploring with systems right now and with how expensive things are getting, I think we're looking toward doing node sharing more if that's not the way of the future. And regardless of your opinions about that, I think that's going to open a huge can of worms for co-scheduling and resource allocation and security. We put security at the bottom because it's important, but it's not my area.
That's you first.
Exactly. But I briefly touched about that with the quantum brilliance emulator situation, but that's me. I don't remember how many minutes that was. It may have gone over, but that's all I got.
Okay, thank you.
Mhm.
About allocation balls.
Yeah.
Two parts. One, how do you identify users? Is it just a typical UID, GID with an LDAP or something?
Yep.
And then what are you provisioning for allocation? Is it clock time on a CPU?
So right in that, yeah, for historically, it's been no doubt here. And so that's my point. Like for quantum, if that's something that I don't know we have figured out yet, right?
That's
We're
why
like,
I'm asking the question.
yeah, I know.
Well, what would you want, I guess?
It comes down to, is the QPU allowed to be multiplex or not? Can multiple users be on it or not? That's the thing that will help influence things, but I don't have a good answer for that, unfortunately. I think that's more of like, I'm putting this out here.
Error handling puts curveball in this because that's error free time or